So you have the original equation, which is f of x equals x to the fifth minus 2x cubed plus 1, and there's your graph. So to find critical points and the max and the mins, you have to take the derivative, which you get f prime of x equals 5x to the fourth minus 6x squared. You set that equal to 0 when you solve, and that gets you x equals 0 plus or minus square root 6 over 5. You plug that into the line test. And you get positive to negative for negative root 6 over 5, so that gives you a maximum. 0 stays negative on both sides, so there's nothing. And then you go from negative to positive for positive root 6 over 5, so that's a minimum. To find inflection points and concavity, you do the second derivative, so that you get f double prime of x equals 20x cubed minus 12x. You set that equal to 0 and solve, and that gives you x equals 0, and then positive and negative root 3 over 5. You plug that into the line test, and you get it's concave up, concave down, concave down, concave up. So then this gives you, and then these are the other graphs. So that gives you have no asymptotes because the original equation never equals 0. You have a max at x equals negative root 6 over 5, a minimum at x equals positive root 6 over 5. It's concave up from negative infinity to negative root 3 over 5, positive root 3 over 5 to positive infinity. It's concave down from negative root 3 over 5 to positive root 3 over 5. The end behaviors of the original equation are that as x goes to 0, negative infinity, y goes to negative infinity, and then as x goes to positive infinity, y goes to positive infinity. Then, because of the second derivative test, you know that you have inflection points at x equals positive and negative root 3 over 5, and you know critical points from the first derivative test at x is positive and negative root 6 over 5.